Hi dear students, we are going to study about basic concepts of vector in analytic plane, and we are going to start with the position vector. Here as it defined, let's say there is a vector AB, and here it is placed where the initial points are x2, y2 and x1, y1. So from this point to this point, when it is drawn, because A to B, also from the name A to B, the vector also shows that one. So this becomes our vector AB. And the position vector here, from the definition, position vector of AB is the same vector when it is moved to initial point, moved to origin. This is called the position vector. Same vector I can draw like this here from the graphs. I can use, let's say, this one with different color here. And from this point, actually, let's start from this point to this one. This is our vector. It's going to be, and if you see here, when I select only that one, and here I'm moving the center, the initial point to the origin. When I move to origin, you're going to see that same vector, only it starts from the origin, and this vector, it is called the position vector of the original vector. And mathematically, we are calculating the position vector with here OP, it's shown, the center generally shown with O letter, and OP is equal to AB, it should be like that also. AB minus OA, which is equal to XY here, X2 minus X1. Actually, this part is not important. We can ignore that part. X2 minus X1, Y2 minus Y1, we are going to find. Here, let's do one example. Find the position vector of KL, which endpoints. Now I'm going to choose 2 points, K and L, and these points are 2, 1 here. This is, if I mention as 2, and this is 1. This is the initial point, which is equal to 2. And the second point is 4 and 5. This is on the x-axis 4. On the y-axis 2, 3, 4, 5. This is the point. Here the intersection point of both of them. Here it's going to be. So this is the second point. And the position vector of KL. Firstly, let me draw the KL, and then I can find the position vector by using the formula. Here it's already selected, and I'm going to use different color for that one here. And let's draw from this point to this one. I said I'm going to use different color. Okay. Actually, I have started a bit upper part, but let's say here it is. Okay, this is the position vector. Pardon, this is the KL vector, this is KL, and I'm going to find the position vector. First, I made the copy of it, then I'm going to move to this side. And here, as you see, it started from here. I'm going to copy one more time. I didn't understand, but there is no arrow here. I'm going to make arrow by myself. Here, as you see, this is our position vector it become, and with respect to this one, with respect to this information, our position vector should be at 2 and y is equal to 4. So x is equal to 2 and y is equal to 4 is our position vector. By the way, here we are getting the origin is 0, 0. That's why 2 minus 0, 4 minus 0. Also, we can understand like that, like formula 4 minus 2 and 5 minus 1. How it makes 2 and 4. 2 and 4. It is same for the position vector. It should be. Okay. What I mean here, if you are looking for the KL, actually, let's say the position vector, it should be equal to, let's say, U. If you are looking for U, it should be equal to x2 minus x1 and y2 minus y1. Here the important part, at the same time, always this one here, L, should be x2, y2, and K should be x1, y1. Here, there's no option. Always we have to choose like that. So with respect to this, here our position vector u is equal to 4 minus 2 and 5 minus 1. Our position vector is 2 and 4. It's going to be, and as you see here, by graph we found the same thing also here. Okay, let's continue with the. Now we are going to continue with the components of the vector. Here, as you see, there are two components, u1 and u2. Also, here you can show the components by using the matrix form, and this is the relation between the matrix and the vectors also. Here, ux, there are two components, x component and y component. I think the ux, it should be u1, 0, which coordinates u1 and 0. And uy, it should be the second coordinate, 0 and u2. So basically we can say like this: ux is u1 and u2 is uy. It has to be. So if I draw one coordinate system here, if I say this is the origin here, basically I'm going to try to draw with simple form. I'm going to draw with different color. Let's say here I'm going to draw from this point to this point, and this is going to be my new vector. And here, since it is origin, the u vector, it's going to have two components, which is equal to the x value is 3 and the y value is 2. So if I write the components of these vectors like ux here, this is the ux, which is I have to draw this one up, but to show that one where it is here, this is ux, and as you see, if we start from the origin, this is also 3, 0 vector, and here u1, 0, which is 3, 0. Also you can say as a 3, the length is 3, and the second one is here. Second one is, if I use different color here, this is the second part, the second component. This is uy, and as you see here, the coordinate, when you check this point here, I'm talking about this point, and this is 0, 0, the position vector this is, so it's going to be equal to 0 and 2. And uy is 0, 2, ux is equal to 3, 0, like this is u1 and u2, whereas 3 and 2. So by using the u1 and u2, we can easily calculate ux and uy, two components of the vector. And here, if our vector is not position vector, this is not position vector, you remember that we were finding by using x2, x1, and y2, y1, the values of u1 and u2. x2 minus x1 was u1, x2 minus y2 minus y1 is u2, so the position vector moves here, and you can calculate from here the position vector, the length also here, there is length of the position vector, which is u here is equal to square root of u1 square plus u2 square, it should be. And also, if it is not a position vector, by using this formula I'm writing here, it should be equal to x2 minus x1 square, which is u1 square here, and y2 minus y1 square. This is for position vector, the formula for position vector, and this is for the whole vectors. It should be. Okay, then we are going to solve these questions here and find the length of each vector. Let's use different color here. U is equal to distance of u is equal to square root of 2 square plus minus 3 square, which is equal to root 4 plus 9, which is equal to root of 13. We cannot reduce the form, so we are going to keep like root 13. Second one, it's going to be v vector. The distance of v vector is equal to, here also it looks like position vector. Here the distance, the length, one of the length, it's going to be at the same time the distance also. Here it's going to be equal to 3 square plus 0 square, which is equal to square root of 9 plus 0, which is equal to square root of 9. That's equal to 3. So the distance is equal to 3 units for this one. And the last one, W. W here. The distance of W, we are going to use the same formula, 3 over 5 square plus 4 over 5 square, which is equal to square root of 9 over 25 plus 16 over 25 it's going to be, which is equal to root 25 over 25. That's equal to root 1, and it's equal to 1. So if the value is equal to 1, the distance is equal to 1, it's also called unit vector. Okay, let's continue with the other questions. Here, this exercise for the length of the vector without, with initial point and terminal point. This is not position vector, and we are going to use the formula that I told you before. Here, I'm going to rewrite the formula again here. So the length of u here, it's going to be equal to x2 minus x1, which is u1, square plus y2 minus y1, which is u2. Square it has to be. Then here the formula, it's equal to, this is equal to sign. Okay, let's continue. Then it's going to be equal to 3 minus 1 square plus 6 minus 2 square, which is equal to square root of 2 square plus 4 square, which is equal to square root of 4 plus 16. That's equal to square root of 20. It's going to be, which is equal to 4 times 5. That's equal to 2 root 5. It has to be. Okay, so we found the length of the vector, and I'm looking for another solution here. There is a vector with the distance is 2 root 5, and then points are A and 2, B 1 and 4. Here I'm going to write the same formula what I have written before. The length of AB, it has to be equal to, by using the formula, the same formula, x2 minus x1 square plus y2 minus y1 square, it has to be. Okay, then here x2, and this is x2, y2, x1, y1, which is equal to, here the distance, it's equal to 1 minus a square plus 4 minus 2 square. And here this is 2 root 5, it has to be. And you know, from the property solution of the equations, if we are going to get the square of both sides, then we can get rid of this square root. So here this is 4 times 5, it has to be, and this is going to be equal to square root, we are going to remove, and then it's going to be equal to 1 minus a square plus 2 square, it has to be, which is equal to 20 here, and that's equal to 1 minus a square plus 4, then 16 is equal to 1 minus a square, it has to be. And if 1 minus a square is equal to 16, you know, from the rules, if I say square root of 16 is equal to square root of 16, what I ask, it's equal to 4. But if x squared is equal to 16, then x should be equal to 4, or x is equal to minus 4, it should be. That's why here 1 minus a, if 1 minus a squared is equal to 16, 1 minus a, it should be equal to 4, or 1 minus a should be equal to minus 4. Then here 1 minus 4 is equal to a, and a is equal to minus 3. Minus 3 is equal to a. Let's write on the same side. And minus 3 is equal to a. And if I send 1 plus 4 is equal to a, and here 5 is equal to a, it's going to be. So there are two values for a, and this is the end of our video.